Okay, today we're going to look at why light refracts. Basically, why do lenses work? Why does light bend? That's what refraction is. Refraction is the bending of light when the index of refraction changes. Now, quick review. The more dense something is, the more light slows down. Light in air is at 3 times 10 to the 8th meters per second. As it enters something more dense, the light will slow down. Now, if it hits at a 90-degree angle, slowing down is basically all that's going to happen. It'll keep going straight. The index of refraction, remember, is the ratio of the speed of light in the substance to the speed of light in air. The symbol's n, and it doesn't have any units. So you just divide c, which is always 3 times 10 to the 8th, by whatever your velocity is. That's what the index is. Now, the index is actually based on the density of the material, and it's calculated experimentally for each object. We've actually got a book at the back of the class that has hundreds of these for different objects. So for example, air is 1, water is 1.33, glass is 1.52, diamond is 2.42. Now, and also if you look on page 454 of your textbook, you'll find a whole bunch of them. So these aren't something I expect you to memorize. And remember, what they really are is the higher the number, the slower light goes in that material. Now the neat thing about light changing speed is, if it doesn't hit straight on, if it hits the surface at an angle, when it changes speed, it will actually bend. The light ray won't be going in the same direction as it passes through the medium. Now we can find the amount it bends from something called Snell's Law. That's this fancy over here. So what this really means is, N1 is the index of refraction that the incident ray comes in. So it's the medium that it starts in. The sign, well, I'm sorry it says Q1. It should say theta 1, but this program seems to change all my thetas into Qs. I apologize. So that's the angle from the normal of that incident ray. N2 is the medium it's going into, and theta 2, or in this program's mind Q2, is the angle of that transmitted ray, the refracted ray. So, for example, here's a good question. If light's going from air to glass, so air is n equals 1, glass is n equals 1.52, at an angle of incidence of 30 degrees, what's the angle in the glass? Now remember, the first step is always writing out what you know, putting it down here, and writing out what I'm asking you to find, because the biggest mistake people will make is solving for the wrong thing. Next step, write out the equation. By the way, if you've done that, you've already got 2 out of 4 marks on the question, because after this, really, we're just plugging numbers in and seeing how well you can use your calculator. We rearrange it by dividing both sides by n2, plug in the numbers, run it through a calculator. Now, one really important thing, this is the sine of the angle. You don't want that, you want the angle. So what you have to do is hit the inverse button on your calculator and hit sine again. And that will tell you what the angle actually is. Please, if you're having trouble, let me show you how to use the calculator. This would be as hard as these questions would get. Why is it harder? Well, one of the ends isn't 1. Again, write out what you know, write out what I'm asking you to find, copy out the equation, plug in the numbers, get an answer, inverse sine, you find it's 17 degrees. So the whole trick to physics isn't about being brilliant. It's about following the steps, being persistent, because you'll really quickly realize that there's only one question I can ask you. Other than that, I'm just changing what numbers you're plugging in. All right, so to sum up, in general, when light goes from a fast to a slow medium, so when the index of refraction gets bigger, like we're going from air, which is 1, to glass, which is 1.52, it will bend towards the normal. If you'll notice, the angle isn't as steep in the glass as it is in the air. When light goes from a slow medium back to a fast medium, the light bends away. The angle, the theta, gets bigger. There are some actual applications to this. This is why if you ever tried grabbing a fish underwater, you miss. It's because the fish isn't where you think it is. We actually call this apparent depth. For example, the light from the fish coming out bends away, but you don't know that it bent, so you just follow the line along and you think the fish is actually somewhere else. That's why if you're trying to grab a fish, and actually your cat knows this, you actually hit the water a little deeper and a little closer than the fish actually is. Here's a really practical application, and it's the question I'm leaving you with right now. Say a person gives you a crystal they say is diamond. If you shine light at it from air at an angle of incidence of 35 degrees and measure an angle of refraction of 21.7 degrees in the crystal, you can actually tell if it's diamond. So here's what I want you to do. Go back through this project, through this video. I've given you the index of refraction of diamond. You've got the equation. Try and solve it and see if it's actually diamond. If you can do that, you can do anything I'm going to ask you with Snell's Law.